Okay, so this is 3.12, and it starts with this launch. We've done these before, where we can use some tracing paper again and try to, we're going to copy this angle, ABC it says, and draw a line called DC, because right now there's no letter D, there's no line for DC drawn in, so that ABC and DCE would be corresponding angles, and we want to show that they would be congruent. And so then we're going to see what appears to be true as we do this. So if you want your own tracing paper, feel free to grab some too, but I'm going to go ahead and, again, just like yesterday, show what happens with this tracing paper here. So I'm going to trace out ABC. That's all I'm tracing onto my tracing paper here. So here's A, B, and C. Okay, now that I have this angle, it's saying here that you're trying to draw a line so that DCE, and I don't have a DCE yet, but we do have a CE. So if we were to kind of move this along here to where C and E are, I want to put D in a spot so that I can draw this exact same angle. So I'm kind of pushing harder with this tracing paper. When I go back to this sheet, I'm going to draw in this line here and label D here, so that I've just created this line so that these two angles, ABC and DCE, are congruent, and you can see that they're corresponding angles, right? So you don't have to actually use the tracing paper necessarily, because you can just estimate how much that is. And I'm going to extend this line because that's what it is. It's a line. It's not just a ray. And that's what that could look like. I could even extend it out further down here. Now you could pick the location of D. It can be literally anywhere on this line. I put it right here. You could have had it further down, further up. It doesn't matter. But as long as you have that line, now it says what appears to be true. And you might say, well, shouldn't we not assume anything? Like, we shouldn't just look at it and decide that's the case. But this is actually using a postulate that we're going to see here, and it's just a second on the next page. But we see here that AB, line AB, is parallel to line DC, or CD, however you choose to write that. So those two lines are actually going to be parallel because these corresponding angles were congruent. I drew it in a way so that I could make sure that these lines were actually parallel. So I could draw in the parallel symbol if I want to. Okay, so that's kind of just an introduction to what the postulate's about to say, because today we're about to do the converses of all the theorems that we saw yesterday, the theorems and the postulates from yesterday. So we are on, in case you're wondering what we're doing today, on the back page here, we have just these 4 left on this yellow sheet. We did all 4 of these yesterday with the parallel lines. Now we're talking about, what about if these angles are actually congruent or supplementary, then we have parallel lines. So you're trying to show today that when something is true, you're going to end up with parallel lines instead. Instead of starting off with parallel lines, we're going to end with parallel lines. So even when you get to the proofs, sometimes you may have a given that says line A is parallel to line B, but then your proof should also say something about line C is parallel to line D, or something like that, where the goal is to try to use one of these theorems or postulates to see how are we going to end up with parallel lines. Okay, so before we can get to the actual proof, let's make sure we know what the different theorems and postulates are. Here's the first one. It says, this is the converse of the parallel lines, postulates, and theorems. The first one is the converse of the corresponding angles postulate, and it says, if 2 lines and a transversal form corresponding angles that are congruent, then the lines will be parallel. So it's telling us that if, for example, angles 2 and 6 were congruent in this diagram, but notice there's no symbol for parallel lines. You can't just say, well, why were they able to say they're congruent then? That was our given. So our given told us that angle 2 and 6 are congruent. Then you can say, because of this postulate, that line L would be parallel to line M. You would only be able to do this if we actually knew angles 2 and 6 were congruent, and we know 2 and 6 are corresponding. So this is how we write it on the yellow sheet. This is the shorthand. If corresponding, and if you don't want to spell out the whole word corresponding, you don't have to. You can abbreviate that. Angles congruent, then lines parallel. Okay, so that's the theorem, or in this case it's actually a postulate, but it doesn't really matter which one. I'm going to highlight it because that's what you're going to use on proofs. Anytime you realize that corresponding angles are congruent, you're able to say then that the lines are parallel. Same idea on the next one. It says now, if the converse of the alternate interior angles theorem will say if two lines in a transversal form alternate interior angles that are congruent, then the lines are parallel. So it says here, if angles 4 and 6, which are alternate interior angles, are congruent to each other, again, we don't see anything about parallel lines here, but that's our proof. Then it ends up being L is parallel to M. Line L is parallel to line M. But it's not marked in the diagram because we're, again, proving the lines are parallel after we know some angles are congruent. So this one we would write if alternate, so ALT can be abbreviated, interior can be abbreviated, angles congruent, then lines parallel. Okay, and that's the second one, that this is a theorem this time. Now we could prove this theorem with the alternate interior angles theorem. We could prove the next one that we're about to see with the consecutive interior angles theorem. We could even prove the last one, which we are going to actually do, the converse of the alternate exterior angles. That's the only one we're going to prove together, just so you can see how it's done. Like that, generally, whenever you see a new theorem on this yellow sheet, you should really understand the proof for it. Yesterday, we did not prove all 4 of those. We could have. But again, if you're curious about that, you can just check the textbook because it does walk through that. But let's go through the last one. And it says the converse of the consecutive interior angles theorem says if two lines in a transversal form consecutive interior angles that are supplementary, right, then the lines are parallel. So again, this time they're not telling us that they have congruent angles. We don't know that they're congruent. Instead, it's saying that if like angles 3 and 6 were supplementary, or that the measure of angle 3 plus the measure of angle 6 is equal to 180, that's enough to show then that the lines are parallel. Okay, so this would say if consecutive, and you could abbreviate consecutive even just CONS. I just wrote a little bit more than that. Interior angles supplementary, I'm not writing congruent, then lines parallel. Okay, and that's the third one that we just saw. The fourth one isn't in a box like these because we're doing it kind of further down so that we can prove it. And that'll be kind of the end of our lesson, but we will practice one on the next page with the actual proofs of how do you use these, because we want to see them in action. But before we can get to that, let's make sure we can prove this theorem, which says the converse of the alternate exterior angles theorem. It says, using the picture below, determine what the given would be in order to prove the converse of the alternate exterior angles theorem. I know we didn't write it officially like this, so if you want to add it for yourself somewhere, I'll write it at the bottom, actually, of this proof. But it's going to be the same exact thing as this, except change the word interior to exterior, right? That's the only difference there. So we're going to use the picture below to try to fill in our given and our proof, and then we're going to do the proof for it without using the actual theorem. Because remember, when you're trying to prove a theorem, you can't use the same one. But we can use any of these if we want to, because those are already done for us. Okay, so let's start with looking at the diagram. We have, if we're trying to figure out which alternate exterior angles that we want to pick, you can pick either 2 and 8, to be given that are congruent because those are alternate exterior angles, or 1 and 7. It doesn't matter which one. I go ahead and pick 1 and 7, but really, again, you could have picked the other alternate interior angles, alternate exterior angles instead. Because remember, there's 2 pairs of them. So we're saying that in our given, we know that 1 and 7 are congruent to each other. And we're trying to show that line P is parallel to line Q. We're trying to show it because look at the diagram. It never actually shows that those are parallel. We don't know that they are. They look like they are, but again, we can't make any assumptions without the proof. So we are trying to prove this theorem. That means we can't use the actual theorem and be done in one step. We can still do our given, where we write angle 1 is congruent to angle 7. And now we have to figure out where to go next. Because again, we don't have any parallel lines. We can't use any of the theorems from the top here. I can't do these because I would need to know if they're congruent and if I can do show that they're parallel. I will eventually hopefully be able to use one of these. If I can show that either alternate interior angles are congruent or corresponding angles are congruent, then I'll be able to use one of these. So in order to do that, you might be looking at the diagram and saying, well, then what? What else can I do? And so here's where you have to kind of jog your memory from last week. And the other angle pairs that we know are true are like vertical angles, for example. We know vertical angles are congruent. So I could bring up angle 3 and 1 are the same, or I could say 5 and 7 are vertical angles and they're going to be congruent. You get to pick which set of angles you want. But I'll go ahead and pick if vertical angles, then angles congruent, and I chose angle 1 was congruent to angle 3. But again, you could have done angle 5 and 7 as well. You might say, well, why aren't you picking like 2 and 4 or 6 and 8? Those ones don't include any of these angles that are already here. So you want to pick one of them that repeats itself like this so that we can do transitive. Because remember, that's what we do when there's two of the same angle. Dealing with congruence, I cannot do substitution. Remember, there's no such thing as substitution property congruence. And I can't do the equal one because I have no equal signs. So again, if you want to use that little highlighter trick to help you remember, well, which things are actually congruent, this would be the ones are the same. 7 and 3 will be the ones that end up being congruent to each other. And it doesn't matter which order you put them in. So I'll just say angle 7 is congruent to angle 3. And then looking at our diagram, what do we know about angles 7 and 3? Now that they're congruent, what type of angles are there? Corresponding. And so I can use this one up here. If corresponding angles congruent, then lines parallel. But the tricky part about these theorems and postulates is they don't tell you what type of angle it is that you just discovered are congruent. You have to look at the diagram yourself and say, what do I know about 7 and 3? Those are corresponding. And if corresponding angles are congruent, then I'll know my lines are parallel. So if corresponding angles congruent, then lines parallel. And I'll write down my two lines that I wanted to show are parallel are P is parallel to Q. Okay, and at the bottom here, I'm just going to write down what the alternate exterior angles theorem was in terms of what's on your yellow sheet, because like we did that up at the top with the three of them, I want to make sure you have the last one as well. If alternate exterior angles congruent, then lines parallel. Right, that's the last one. We just proved it using a different theorem, of course, a different postulate, because we can't use the same one. But we could have done a different proof for the other theorems as well. I just didn't want to take up time doing each one, because that would take a lot longer. Okay, so what we're going to do is on the next page, we're just going to do one of the proofs that are there. There's a total of, I believe, 3 proofs. But we'll go ahead and just do one of them together, just so you get the gist of it. And then you can try out numbers 2 and 3 if you'd like to, or you can come back to those at any time as well and try them out if you'd like. Okay, so let's go ahead and do number 1 together. And all of these proofs, they can be done, well, I should say numbers 1 and 2 can be done in about 4 steps, but number 3 is definitely a harder one. It takes a little bit longer, so if you decide you want to try number 3 out and you want some extra help with it, let me know and I can kind of come help with that. Just so that you know, for Monday, there is this Find the Fiction review, like a warm-up here, and more practice on this page. That's like a team pair solo that you can do as well. And then that's kind of it for the review for the quiz. The test has a review itself. I'll remind you about this on Wednesday, because we'll have time in class to work on that. But let's go ahead and start on number 1. The diagram here shows me that I have a bunch of these. I have like 2 lines that kind of appear to be parallel, but remember, if it's not labeled as parallel, you can't make any assumptions yet. We're trying to eventually prove that those 2 lines are going to be parallel. EG, which is this one. Actually, we're going to prove this line is parallel to this line. And I know that BH is not extended out, but you can extend that line out because we're about to look at it as the entire line. And then we have 2 transversals then, so you'll have to kind of cover up one at a time as needed. But let's mark the diagram. We have angle 1 is congruent to angle 3. And I have angles 2 is congruent to angle 3. But and because 3 kind of repeats itself here, you could technically put the exact same ring around 2, or you could like put 2 rings around. It's just going to be confusing if you try to put 2 rings around 3, even though it's the same as 2 and as 1. because that's kind of where we're going to start this proof right away with this idea of transitive, right? Because right away when you see that some of these angles are the same, this one and this one specifically, then you could do transitive with the other two. Okay, so I would recommend doing that kind of right off the bat to see where is it going to end up. But before I can do everything else, it will help if you kind of make sense of the diagram, because there's a lot of transversals to keep track of. If these are the lines we're trying to prove are parallel and we don't know anything about the other two lines being parallel, we can't use that information. So if, here's a common mistake. Angles 3 and 2 look like corresponding angles, and you're not wrong, they are corresponding angles, but which lines have to be parallel for these corresponding angles? Anyone see which ones, Ethan? Yeah, CD with AB, is that right? And then the transversal is this EG. But remember, we don't know that CD and AB are parallel. Could I show it? Sure. You could possibly say because angles are congruent, angle 3 is congruent to angle 2, you'd be able to show that those two angles would then be showing that they're corresponding, and that it would show that the correct lines would be congruent. But here's what ends up happening. Let's see here. If I do my given, and I write out all those angles that are congruent to each other, and then I do my transitive, because that's the first thing that comes to mind when I see angles that are the same and congruent to something else. So by doing transitive property, I would see that 1 and 2 are congruent to each other. Not angles 2 and 3, even though I could see that from the diagram that those are corresponding, but hopefully you also see from the diagram that angles 1 and 2 are corresponding. So you kind of just have to cover up that extra line right there, and we're not caring about angle 3 anymore. We got rid of it because it was corresponding, or it was the one that was the same for transitive. But now this is the transversal I want to use, transversal, for the two parallel lines I'm trying to show are parallel. Okay, and 1 and 2 then are corresponding again. If you need to like turn your paper to see it a little bit better, you can definitely do that and see, okay, those are corresponding for this transversal with the parallel lines that I'm trying to prove are parallel. Okay, so step 3, which is the last step here, is going to say if corresponding angles congruent, then lines parallel. And this time, just make sure you're writing down the correct lines that you're trying to show are parallel. Don't say CD and AB, because we don't care about those. We want EG and BH. All right, and we are done. This is that short of a proof. That you don't have to do anything else, because we already proved that since 1 and 2 are congruent and they're corresponding, then these would be the parallel lines that go with 1 and 2 with this transversal. All right, anybody have questions on that one? If you want to try out a second one, number 2, just a hint on this one as you're trying it out. This one's harder because it does say the word supplementary. It doesn't do congruence, unfortunately. So this one, unless you can eventually show two angles are congruent to each other, then hopefully you can use the piece about if alternate whatever or corresponding angles are congruent, then lines are parallel. The hint I'm going to give you on this one, if you'd like to try it, is to use this one theorem that we saw last week, or maybe it was the week before, this one here. If angles supplementary to the same angle, then angles are congruent. By using this theorem, you can notice that we have like 1 and 2. Looking at 1 and 2, 2 and 3 are a linear pair. So if I can say that if they're a linear pair, then they're supplementary, and then I see that angle 2's are the same angle, I can use that theorem to kind of keep going in the proof. It only ends up being like 4 steps if you do it that way. Okay, if not, and you want to use like the definition of supplementary, which is on the front page, it ends up being a longer proof, but you can also use this one. If two angles supplementary and the sum of the measures is 180, it's a perfectly fine proof, but it ends up being like 7 steps, unfortunately, when you have to do it that way. Okay, so if you'd like to just do number 2 and number 3, feel free to try those out, and then there's even the warm-up that you can start with, or you can wait till Monday to try some of that. The rest of the time, you're going to go ahead and